Lesson 4.7, picking up where we left off yesterday. And as we pick up where we left off yesterday, we pretty much finished inverse sine, right? And I'd started talking a little bit about inverse cosine and inverse tangent, but I think that's about where we left off in this class. Disadvantage, the side chart isn't filled in today. We can't just look over there. You're going to have to flip back in your notes or see how well you have it memorized. But it'll be back up there tomorrow. I just have to leave it blank for afternoon yet. So, if you recall, and I know my BenQ erased overnight, so we had sine inverse yesterday, right? With sine inverse yesterday, remember the domain was -1 to 1, so that was our input. The range was -π/2 to +π/2, and that was the right half of the circle. Okay? Now, today, we're talking about inverse cosine and inverse tangent. So, again, you can use, when you're doing it via calculator, you can use the second cosine and second tangent functions. These can also be written as arc cosine and arc tangent. Now, as you look, okay, so cosine, inverse cosine, has a domain of -1 to 1. Same exact domain as what inverse sine had. However, our range is 0 to pi. And that 0 to pi is what changes. And if I go over here, I think they're in the next slide. Notice cosine. When we look at cosine inverse, and remember these are the range values. When we look at these range values here, now our output is from 0 to pi. And it is just that, 0 to pi. There's nothing fancy about other names or anything here. We don't go negatives or anything. It is 0 to pi. Excuse me. So cosine inverse I always remember as the top half of the circle, whereas sine inverse I remember as the right side of the circle. And then we talk about the inverse tangent real quick. Inverse tangent has a domain of -infinity and +infinity. And this will make a little more sense after we talk about the graph. But the idea of inverse tangent is you can have any input. There are no restrictions on what our input it can be. Any real number will work. The range is -π/2 to +π/2. Notice it says similar to sine. Why is it slightly different from sine? These are parentheses, right? Up on sine, it was bracket. So on sine, it could include -π/2 and +π/2. On inverse tangent, it goes all the way up to -π/2 and +π/2, but it does not include them. And so that's why when you see on these half circles, you'll see the x here saying, okay, it goes all the way up to that point, but it does not include that exact -π/2 and +π/2. Again, it's the right half of the circle, and just like with inverse sine, quadrant 1 are the normal angle names. Quadrant 4, you have to start at 0 and go down and use the negative names. Okay? So let's look at some of these examples. Sorry, no more calculator examples today. I think you had the calculator figured out though, so I think you'll be fine with that. These are find the exact value without using a calculator. So, A. Sorry. Cosine inverse. Cosine inverse of -√2/2. So first of all, kind of like yesterday, I would suggest, why don't we check the domain? Kind of always want to keep that in your back of your mind that, okay, we got to check the domain. Is that a good domain value for cosine inverse? Cosine inverse, the domain is -1 to +1. It's -√2/2 in that area. And I would say yeah, because I know the square root of 2 is about 1.4. And when I divide that in half, it's going to be about 1.2. So, or try that again. Half of 1.4 is going to be about 0.7 negative. So, okay, so my domain works. What are your thoughts here? At what angle does cosine equal square root of 2 over 2? And I would not worry about the negative quite yet. We need to figure out what angle we're talking about in general. So what angle does cosine equal square root of 2 over 2? Well, we don't have the chart. No one's going to give me quick answers here. Pi over 4. Okay, because that's the one where sine and cosine have the same value, right? Cosine of pi over 4 and sine of pi over 4 are the same. Okay, now, so if this said cosine of positive square root of 2 over 2, our answer is pi over 4. Now, this is negative square root of 2 over 2. Well, let me go to the backside for a moment. So right here, we're talking pi over 4. So we're talking that angle right there, if it's positive square root of 2 over 2. However, what quadrant do we have to go to since it's negative square root of 2 over 2? And we're going to go over here to quadrant 2 because that's my only other option. Okay, and if you think about all students take calculus, all students, sine is positive, cosine is negative. So this is a good quadrant. So we need to know what is the equivalent angle to pi over 4, but in quadrant 2. Thoughts? What was it? 3 pi over 4? Because if I draw my picture on the other page, okay, this is pi over 4 up from the x-axis, right? What's equivalent to pi over 4 up from the x-axis here? And that is 3 pi over 4. Okay? So, and what I would say here is think, this is the kind of work I'll put down, think pi over 4 in quadrant 2. That's what you're going to have to think to get your answer, right? And that answer then, pi over 4 in quadrant 2 is equivalent to 3 pi over 4. And is that an acceptable range value? It's 0 to pi, isn't it? It wouldn't be for inverse sine, but it is a good range value for cosine inverse. So this is where cosine and sine are different. Had we been working with sine inverse, we would have just been able to say, oh, pi over 4, so we need to say negative pi over 4. Because it's cosine, we have to back up to that quadrant 2. Okay, let's try B. Tangent inverse of square root of 3. First of all, is my domain good? It's tangent inverse, and domain of tangent inverse is anything. So yeah, my domain's good. At what angle does tangent equal square root of 3? Pi over 3. Okay. Use that chart, right? Because it's a positive square root of 3, we're going to be in quadrant 1. So it's just your typical pi over 3. If that had said negative square root of 3, we'd have to go down to quadrant 4. And so we would say negative pi over 3. But since it was positive, it's positive. And that's between negative pi over 2 to positive pi over 2, right? 1/3 is less than a half. And so that's a good range value. Okay. Ready to try C? Cosine inverse of cosine of negative 1.1. Well, first of all, I see parentheses. So where am I going to start? Yeah, we're going to start inside the parentheses. Cosine of negative 1.1. First of all, this is a regular cosine here, isn't this? Isn't this? Holy cow. Isn't it? Okay. This is a regular cosine, which means negative 1.1 represents an angle. It's not our typical angle form, is it? That's okay. It represents an angle. Okay. Do you know the cosine of the angle 1.1 or negative 1.1? No, because we don't even know what that 1.1 is, do we? Okay, that's not one. On our chart, we have pi over 6, pi over 4, pi over 3. We can talk about our quadrantals like 0, pi over 2, pi, 3 pi over 2, and 2 pi. But that's not in here either, is it? Okay, so we're going to have to do a little special case thing here. Thank you. Okay. Let's see. Let's sketch a drawing here. Negative 1.1 is an angle, correct? Is this radians or degrees?
Radians.
Radians because it doesn't say degrees. Okay? It would have to have a degree bubble. Otherwise, we know it's radians. Not your typical radian form, but. So, negative 1.1. If we start thinking in terms of radians, here's 0. Here's pi over 2. Pi. Actually, I guess this is negative, so really I should go. This is 3 pi over 2. But in terms of negative, it is negative pi over 2, right? Okay. This technically would be negative pi. It's plus or negative pi, right? How's that? That's weird if I say plus or minus pi, but it is, right? It's positive pi going this way, negative pi going this way. Okay. What quadrant does negative 1.1 land in? No?
Quadrant 2.
No? Not quadrant 2.
4.
Quadrant 4? I can agree with quadrant 4. So negative's going to take me down, yes. If we think in terms of negative pi over 2 here, pi is 3.14. 3.14 divided by 2 is negative 1.57. So when I say negative pi over 2 here, this is negative 1.57. Negative 1.1 is going to be before you get there. Okay? Now, the reason I do this is because generally speaking, and we haven't done it yet today, but what was happening when early up above when we did sine inverse and sine? They were basically undoing each other, right? When we did sine inverse and sine together like that, or a sine inverse of sine of something, they basically undid each other as long as they were in a proper quadrant. And that's the piece we have to work with here, okay? This is down 1.1. So the cosine of negative 1.1 is related to this reference angle right here, however far this goes down. Now, what do we know about cosine in this quadrant? All, right, students take calculus. So cosine of this angle is going to be a positive, right? So we know that cosine down here is positive. Well, now we're doing cosine. That's the thing. We're not going to exactly know what cosine of negative 1.1 is, but we're going to do cosine inverse of this. So we want to look, cosine inverse, where are my possible answers? They are in quadrant 1 or 2. Where are my positive answers for cosine inverse? Positive 1, quadrant 1. So since this is quadrant 1, we want to know what is the equivalent angle up here in the positive quadrant. So down here, it was negative 1.1. What is the equivalent angle up above in quadrant 1? So if I went down 1.1 to get to this angle, what do I do to get to the angle up here? You're going to go up 1.1, yes? So this angle is 1.1. So when we start talking about cosine inverse, it puts us in this quadrant, or excuse me, cosine, it talks about this quadrant here, quadrant 4. Cosine inverse wants to know the equivalence of that up here, which is the 1.1. So all of that to say the cosine inverse of cosine of negative 1.1 is actually positive 1.1. This reminds me of E from up above. And as I said, my board erased overnight, so I don't have E on my other screen to show you. But when we did E yesterday, sine inverse of sine of 5 pi over 6, my answer wasn't 5 pi over 6, was it? Because I had to change quadrants. This wasn't in a quadrant that could work for sine inverse, because sine of 5 pi over 6 was over in quadrant 2. So we then had to move it to the positive quadrant, which was positive pi over 6. Same type thing happening here. It's just harder to do because we don't know the values. Okay? So cosine of negative 1.1, that put us down here in quadrant 4. This is not part of my cosine inverse quadrants. And so we had to look for the equivalent up in a cosine inverse quadrant. Okay? There's a lot to that one to understand. I hope I've kind of at least brushed the surface and given you a little understanding. It definitely works easier with angles you know, though. Okay? Questions I can answer on that one? Okay. Let's try D. Tangent inverse of 0. Is my domain okay? Well, yeah, my domain's okay because my domain on tangent inverse can be anything. So this is saying, at what angle does tangent equal 0? That's not on my chart, is it? Now, where do the zeros usually happen? When we have like sine equaling 0 or cosine equaling 0 or tangent equals 0, and those are happening on our quadrantal angles, on the axes basically. So, okay, quick sketch. First of all, what quadrants am I working in for tangent inverse?
1 and 2.
Okay, we're working in 1 and 2. So, no, not 1 and 2. I went right with you. 1 and 4 because we're in tangent inverse. I X'd the right things out. I just said the wrong thing. So our answer can be somewhere over here, right? Our answer has to be over here somewhere. Now, when does tangent equal 0? Well, what do we know about tangent in terms of these ordered pairs? Cosine is the x value. Sine is the y value. And what's tangent? Do you remember?
Y over x.
Yeah. Tangent is y over x. So we want to know, when does y over x equal 0? So if we're asking when does y over x equal 0, what value do I need to be 0? How do you make a fraction 0? You have 0 on top, yes? So I want to know at what angle does tangent equal 0? So at what angle does y over x equal 0? It doesn't matter what x is. That's irrelevant. I just need to know when does y equal 0. So where are my places that y equals 0? My options could include what? At 0 degrees, that's 1, 0. At pi, that is negative 1, 0, yes? Those are the two places that tangent in general could equal 0. But what about tangent inverse? Which one do I have to use? Can I use pi? No, because pi, we can't use this side at all, can we? So I can't use pi. So what do I have to use? We have to use 0. So at what angle does tangent equal 0? At 0. I know, it's kind of awkward to say. And that's 0 degrees, 0 radians. I'm just going to put it 0 because, again, we're supposed to be talking radians. So when you see those zeros, think about your quadrantals, okay? One more. Cosine inverse of negative 1. Is this an okay domain? My domain is negative 1 to 1, endpoints included, so yes. At what angle does cosine equal negative 1? Is that on my chart? Do sine and cosine ever equal 1 on my chart? Excuse me. Tangent has a 1, but sine and cosine don't. So I need to go to my quadrantals again. Okay. So we want to know, when does cosine, in an ordered pair, cosine sine, when does cosine equal negative 1? So basically, you're looking for the ordered pair negative 1, 0. Where does that happen at? Negative 1, 0 is at? Where? Pi? Think about it, right? Cosine has to be somewhere up here on top. I want to know when cosine, when x is negative 1, the only place that's going to happen is at pi. So be willing to think about those quadrantal angles. When you see your zeros and ones and negative ones, think quadrantal angles. Unless it's tangent and 1. That's the one time you don't have to think quadrantal. Okay. I know we saw some of the tougher ones today. Some of these types of problems are easy. Some of them are a little tougher. So your homework that is due tomorrow that I want you guys working on right now is page 385, 1 through 20, and 23 through 32.